And good morning, Math Masters. Welcome to another exciting edition of Mr. Leggett's Eureka Math. Eureka is a Latin term. It means I have found it. And what have we found? Why? By golly, we have found the best way to learn math, and that, scholars, is more valuable than gold itself, which goes for about $1,400 an ounce. Believe it or not. All right, here we go. Our objective today, ladies and gentlemen, boys and girls, damas y caballeros, is to decompose unit fractions using area models to show equivalence. Okay, so that's what we're going to be doing. We're going to start off with a fluency practice on adding fractions. So let's write this fraction down. 4/5. Okay, let me just get over here a little more. So 4/5, and let's draw a diagram to represent this fraction. 1, 2, 3, 4, and 5. How many should we shade in? 1, 2, 3, 4. Okay, so we're at 4/5. And let's break this apart, decompose, to show that 4/5 equals 1/5 plus 1/5 plus 1/5 plus 1/5, right? 1, 2, 3, 4/5. Now remember, we could also do this. We could modify this to say maybe 4/5 equals 2/5 plus 2/5, right? 2 plus 2 is 4, 4/5. Or we can just go to multiplication and say 4/5 equals, remember, multiplication is just repeated addition, 4 times 1/5. And that's how we do it. Let's continue on to our application problem. Moving kind of fast today. And we'll read this, find out what we know. A loaf of bread was cut into 6 equal size slices. Each of the 6 slices were then cut in half to make thinner slices for sandwiches. Yum. So we're going to cut that in half, each of the 6 slices. So that's what we got going on. Loaf of bread, cut into 6 equal slices, and then cut in half again to make sandwiches. Nice little tea sandwiches for an afternoon tea. Let's find out what goes on here. Mr. Beach used 4 slices. I'm going to circle that. His daughter said, "Wow, you used 2/6 of the loaf," close quote. I'm going to circle 2/6. His son said, "No, he used 4/12. Who is right?" Let's find out. Okay, we're going to do a tape diagram to show that loaf of bread. Was cut into 6 pieces, right? 1, 2, 3, 4, 5, and 6. How much did he use? He took 4 of the slices, right? And he cut them in half. So let's do 4, shade in 4 lightly. I'm going to use my trusty yellow marker. 1, 2, 3, and 4. Oakland A's colors. So there we're showing already, it looks like it's 4/6. Now the daughter said 2/6 and the son said 4/12. Who's going to be right? Let's take a look. So we know that each one of these slices is 1/6. So we're going to make a little bracket. Maybe Princess Yvonne will come out and put 1/6 here and 1/6 here. All right? So that's how we're looking. We know that that's 1/6 and we know that's 1/6. Now, he cut them in half, right? Crazy Mr. Beach. I like my sandwiches on little tiny pieces of bread. So he goes, dun, 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 right? Do, 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 do. So he used those 4 slices after he cut them in half, right? Let's go back and look. Just do a little review. A loaf of bread was cut into 6 equal slices. We did that. Each of the 6 slices were cut in half to make thinner slices for the sandwiches. So let's cut them in half. So you really got to read carefully. I'll show you why. Mr. Beach used just 4 slices of the thinly sliced bread. So Mr. Leggett shouldn't have colored those in. So we can see now that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They become 12ths after they've been cut in half. So let's go ahead and write that down. Make our little tiny brackets. And I'm just worrying about these slices because he used 4 slices. He didn't use 4 of the 6 full slices. And each one of these is representing, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each of these are representing 1/12. So we're going to write 1/12 on all those. All right, so let's see who's right. I bet you already know just by taking a look at the problem again. Let's take 2/6 because that's what she said it was. Maybe they're both right. Who knows? 2/6, that's what the daughter said, equals, because we have 2 of the 6, forget those yellows, 2 of the whole 6 equals 1/12 plus 1/12 plus 1/12 plus 1/12. What will that equal? Remember, 2/6, 4 1/12. It equals 1, 2, 3, 4. Do we add all those 12s? Of course not. They remain the same. So we can see here that 2/6 is equal to 4 12s, right? Look at this. 2/6, 4 12s, equal. Hot dog. So now, let's just go ahead and decompose further, and we can say that 2/6 equals 2 times 1/12, right? Plus 2 times 1/12. And we can make it even simpler by just saying that 2/6 equals 4 times 1/12. Voila! So it looks like we read, we drew a lot. They were both correct about the bread. Okay, and really write the whole thing down so we really get in the habit of doing this, okay? You go and pause that if you need to. And we'll go on to the next page. Excuse me. We're going to draw an area model to illustrate that 1/5 is equal to 2/10, okay? So let's draw the area model first. Making it kind of big and wide. And we're going to start off with 1/5, correct? Yes. 1, 2, 3, 4, and 5. Okay? So now, with a trusty yellow Sharpie, we're going to model 1/5. Okay, we can all plainly see that that's 1/5. Mr. Lake's not going to blow this one. So, how can I show that it's equal? Well, watch what we do. We need to make these 5 units into 10. How could I do that? Just cut it in half. So we started out up here with 1/5, right? And now I cut it in half. What do I have? Let's take a look. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So it's going to be a 10th, and we're going to 2/10. So I'm going to make my little tiny bracket here. We're going to say that this is 2 out of 10, 2/10. It's division, believe it or not. We'll go into that later. So we can say, without a doubt, by looking at this area model, that 1/5 is equivalent to 2/10. 1/5 equals 2/10. There we have it. Let's go ahead and further decompose this to show more. We'll say that 1/5, remember that's what we started with, it equals 1/10 plus 1/10. And that equals 2 times 1/10, which is equivalent to 2/10. See how we did that? 1/5 equals 1/10 plus 1/10. 1/5 equals 1/10 plus 1/10, or 2 times 1/10. Let's go on to our next problem, problem 2. Problem 2 is asking us to decompose 1/3 is 4/12 represented in an area model and is the sum and product of unit fractions. That sounds fun. 1/3 as 4/12, okay? Be a little more complicated here. Make a nice rectangle. And we'll say we're doing 1/3, right? Right up there it says 1/3. So there's 1, 2, and 3/3. How many am I going to shade into yellow? Well, it's 1/3, so I'm just going to take 1. And I'm going to label this as 1/3. Okay? Now, I got to get it to 12ths. How many times should I cut the rectangle? Well, 3 times what is 12? 3 times the number is 12. 3, 6, 9, 12. So 3 times 4. So I need to make 1 cut. I now have 1, 2, 3, 4, 5, 6. 2 cuts. I have 1, 2, 3, 4, 5, 6. Let's do another cut. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I have 4 rows going this way. So now what we can see clearly here is that 1/3 is equal to how many 12ths? Take a look. 1, 2, 3, 4. They're equivalent. So let's go ahead and decompose these and show them as a product of, as a sum and product of unit fractions. So we would say that 1/3 equals 1/12, right? 1 out of 12 plus 1/12 plus 1/12 plus 1/12. Or we could say 1/3 equals 4 times 1/12. That equals 4/12. Alrighty. Moving right along, let's get to concept development problem 3. We're going to model 1/2 equals 5/10 and represent the decomposition as the sum and product of unit fractions. Same type of thing. Doing 1/2 as, marble. So let's make 1/2. Like so, right? There we have it, 1/2. And let's make it yellow. To represent this is 1 out of 2 or 1/2. You just shade it in lightly. And we need to cut this into 10 pieces, right? We started with 2, but we need to cut it into 10 pieces. So let's think about something times 2 equals 10. 2, 4, 6, 8, 10. So 2 times 5 equals 10. Let's get cutting. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like we've got it into 10 pieces. Remember, we started out on this big block with just 1/2, right? But now what do we have? We have 1, 2, 3, 4, 5 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 5/10. Okay, now let's decompose it. And we say that 1/2 is equivalent to 5/10. And we could prove this by going just right to the point. I'm not going to deal, well, we should deal with it, but I think we know this well enough. Let's do it. 1/2 equals 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10. 1, 2, 3, 4, 5 equals 5/10. Or let's just go over to our simple multiplication, and we could say 5 times 1/10 equals 5/10. Alrighty, get ready for your problem set. You might want to stand up, take a little stretch, pause the video. We're going to go to page 133. And today's date is 03/05 And the year is 2020. All right, let's find out what's going on with our problem set. I'll zoom in a little bit, get a little tighter here, so tiny. Do-da, do-da. Yeah, that's good as good to get. Alrighty, so let's get started on the problem set. See what's going on here. Remember, read. Each rectangle represents one. So each rectangle represents one. That's something we know. I'm going to circle one. The shaded unit fractions have been decomposed into smaller units. Express the equivalent fractions in a number sentence and using multiplication. The first one has been done for us. So basically we made this, we made a 1/2 equals 1 times 2 equals 2 equals 2 times 2 equals 4. So there we have it. Let's see what this originally was. It was 1 out of 2. So that's 1/2, right? Okay. And what happened? It looks like Mr. Leggett has the wrong problem set. I'm thinking, my goodness, this doesn't look familiar. No, not page 133. So sorry. Go ahead and put that back in to your desk and let me get the right page out. 4th grade is on lesson 7. I mean 3rd grade is on lesson 7. That's where I made my mistake. Thank you for your patience. Here we go. Lesson 5 problem. Go ahead and put that one back in your problem set book. We'll get to it on Monday. Monday. All right, here we go again. We're going to page 127. Excuse me, page, 127. Today's date, 03/05/2020. Okay, draw horizontal lines to decompose each rectangle into the number of rows as indicated. Use the model to give the shaded area as both a sum of unit fractions and as a multiplication sentence. So let's take a look at the first one. We started out as 1/4, right? And we decomposed it into 1, 2 out of 1, 2, 3, 4, 5, 6, 7, 8. So we decomposed it to 2/8, or made an equivalent. Let's go over here to decompose. We say 1/4 equals 2/8. And 1/4 equals 1/8 plus 1/8 equals 2/8, right? 1/4 equals 2 times what? 1/8. And that equals 2/8. If you feel comfortable, go on and then just check back and make sure you got it right, okay? Let's look at the next one. We have 1 out of 5, 1/5, right here. Okay? Now we're going to make 2 rows here. So I'm just going to cut it right in half. So there's 2 rows now, right? 1 row, 2 row. So now we have 1, 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 2/10. So we know that 1/5 is equal to 2/10. We're going to prove it over here. I'm going to write 2/10, 1/5 equals 2/10. Okay? Then I'm going to say 1/5 equals 1/10 plus 1/10, and that equals 2/10, right? Okay, let's do the multiplication now. And we'll say that 1/5 equals let's do 2 times 1/10. I could have done 1/10 times 2, but might as well be consistent. And there we go. Let's head on down here. We have 1 out of 3, so it's 1/3, right? And they want 4 rows. There's 1 row. Now we have 2 rows, and then we'll have 3 and 4. 1 row, 2 row, 3 row, 4 rows. So now this 1/3 has become 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's our numerator, 4, and the denominator, the total number of spaces, is 12. So we have 4 twelfths. 1/3 equals 4 twelfths. Let's prove it. 1/3 equals 4 twelfths. And we would say 1/3 equals 1/12. And here we go again. Plus 1/12, plus 1/12, plus 1/12, which equals 4 twelfths, okay? So now we can do multiplication and say 1/3 equals 4 times 1/12, which equals 4 twelfths. And that's how it's done.
Excuse me, Mr. Leggett.
Mathmat, what's up? What's wrong?
Well, I'm looking at this math page that we've been doing, and you have not used any parentheses.
No parentheses were used on this problem. Right here, here, you can see.
Yes, I can see quite clearly. I'm very depressed about no parentheses.
Well, sometimes we just don't need parentheses, Mathmud. It's just the way it goes.
Oh well, back to my doghouse.
You don't have to be so upset. Maybe there'll be parentheses on the back next. There he goes. Oh well, Mathmud. All right, let's take a look at our next one here on 2. It says draw area models to show the decompositions represented by the number sentences below. Represent the decomposition as a sum of unit fractions and as a multiplication sentence. So we're doing the work now. We're saying that 1/2 equals 3/6. How are we going to do this? Let's get it done. We're going to make a rectangle, and we're going to start off with 1/2. Okay, we got 1/2 right there. Now we need to make this into 6 pieces. So 2 times what is 6? 2, 4, 6. 2 times 3. There's 1, 2, and 3. So 1 row, 2 row, 3 rows, okay? So let's prove it with multiplication. And I'm going to cross out B, D, and F. We're going to prove it with multiplication and addition. We would say 1/2 equals, see now, we start off with, let's do our little brackets, 1/2, and now we have 3/6. So 1/2 equals 1/6 plus 1/6 plus 1/6, or 1/2 equals 3 times 1/6, which would equal 3/6, and I can also put equals 3/6 on that side too. Let's do the next one right here. And it says 1/2 equals 5/10. So let's make a 1/2. This will really help you with your homework, so get this done. There's 1/2. Now we need to make that 5 pieces. So how many rows? Let's see what we got. 2, 4, 6, 8, 10. Okay, so I have 1/2, and we need to show that it's equivalent to 5/10. So I need to make 10 pieces up here, okay? So we said 2 times 5 is 10. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 5 of them are shaded in. So we could say 1/2 equals 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10 equals 5/10. 1, 2, 3, 4, 5 equals 5/10. And there we have it. Oh wait, multiplication. 1/2 equals 5 times 1/10, which equals 5/10. That's how it's done. Send it down here to 1/3. Running out of room. We're going to make 1/3 to start off with. And I don't have any room for my bracket, so I'll just kind of circle the 1/3 there and point down there. On the bottom is going to be 4/12, which is an equivalent fraction. It says it's equivalent, it's equivalent. But we need to make 12 pieces, so we only have 3. So 3 times what is 12? 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and 3 times 4 is 12. So I need to make 4 rows. There's 1, 2, 3, and 4. So now I have 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 4 out of 12. They're equivalent. So I will say 1/3 equals 1/12 plus 1/12 plus 1/12 plus 1/12. And that equals 4/12. And then we can go on to show that 1/3 equals how many times 1/12? 1, 2, 3, 4. 4 times 1/12. And we're not doing number 3. And there you have it. Another edition of Mr. Leggett's exciting Eureka Math in the Morning. Eureka Math in the Morning with Mr. Leggett has been brought to you by Math Mud and Calculating Cat.